You can follow along with this presentation using printed slides from the NanoHub. Visit www.nanohub.org and download the PDF file containing the slides for this presentation. Print them out and turn each page when you hear the following sound. Enjoy the show.
What I'd like to ask you, I had prepared some exercises. So I'm just going to, maybe you can take them down as notes. I mean, I'm not going to collect them or anything, it's just for your own benefit. So if you go to your office, I mean, all of you are local here, right? Most of you? Okay. So what I prepared is this. So number one, make sure you have an active account on NanoHub and let me know what that login is. Locate the piecewise constant potential barrier tool. It's a great acronym, PCPBT. Okay, so maybe write down nanohub.org/tools/PCPBT. And play with it a little bit for double, triple, and quad barrier structures. And then start looking at a two barrier structure and increase the barrier heights. And then look at on the position of the resonances. And then increase the barrier widths. And look at the transmission coefficient and the reflection coefficient. And then look at the output of this bulk band structure. This one panel that, do you understand it? It's sort of in what I just showed you, that particle in the box bit, play with it, right? Make the well large and the barriers really fat. The two should agree with each other, because you have states that are low in energy and they see all the same barriers roughly. And they start to deviate as you go up in energy. Let that sink in a little bit and play with it a little bit. Because all of these effects are going to be very important when we start doing real devices. Okay? Then there is a tool called RTD Negative. So nanohub.org/tools/RTDNEGF. Just hit run, simulate, and just see what happens and see if you like the outputs, if you understand them. And then run a Hartree calculation instead of the Thomas Fermi calculation, and look at the charge and the shape of the current voltage characteristic, and look at the traces of the eigenenergies. Take those down. And there's an advanced panel. Turn off the relaxation in the reservoirs, set it to 0, and compute the IV one more time. Okay? And 3 is the tool called tools/QDOT. Just play with it and look at a pyramidal dot. Okay? So you get a little bit familiar. And if you do that, tomorrow's lecture is going to be much easier, because you've seen it, you've seen some facet of it. It doesn't look from like from Mars. Okay?